Hi everyone, and you're very welcome to today's Saturday session, which is going to be focused in on junior cycle science. And our topic for today is going to be Earth and space, but more specifically, we're going to look at celestial objects, the seasons, the lunar phases, and then the two types of eclipses, which we need to know as well. So throughout today's session, we're going to look at the theory behind each one of these, and we're going to practice some exam questions as well, just to see where these have popped up on previous exam questions, how we can approach these questions, and how we can make sure that we can get as much marks as possible in the final exam. So we're going to start off with today with the celestial objects and the study of astronomy. So when we mention astronomy, we're talking about the study of space and everything inside it. Within astronomy then, part of this study of space will involve the study of celestial objects. So a celestial object is just a name for any object that can be found in space. And there's lots of these. So a couple of them will be stars, we've planets, we've moons, asteroids and comets, we've nebulae, star clusters, galaxies, quasars, black holes, dark matter. All of these will be examples. But the ones which we need to know for junior cycle science are our planets, our dwarf planets, our comets, our moons, our asteroids, and our stars. It's vital that we know all of these, and we'll be going through each one of these in a little bit of detail over the next couple of slides. Okay, so the first thing we're going to focus in on here is the idea of a solar system. So a solar system consists of a star, which in the case of our solar system is the sun, as well as all of the objects that orbit it. Now, these objects that orbit the star, they can be any of the celestial objects which we've previously mentioned. So in our solar system, we have the main star, which is the sun. We have all of the planets, Earth, Mercury, Venus, Jupiter, Neptune, and so on. We have lots of moons. We have the planets, as I've mentioned. We can have dwarf planets in there as well. And we have millions and millions of asteroids, comets, meteors. All of those compose our solar system. Okay, so it's the star and all of the objects that orbit around that star. A galaxy then is a big collection of gas, dust, stars, and their solar systems held together by gravity. So in essence, a galaxy is a combination of solar systems. Now, the galaxy that we're located in is the Milky Way galaxy. Okay, there is other galaxies out there as well, yet to be explored, but we can picture them. But the one that we're in is the Milky Way galaxy. All right, so for the next couple of minutes, we're going to focus in on all of the different celestial objects so we can differentiate between each one of those. Now, the main star in our solar system is the sun. Now, by definition, a star is a ball of gas that emits light and heat, okay? And we can see that from the sun. The sun is a big ball of gas. It does emit light, and it does emit heat as well. Now, we know nowadays that the sun is the center of the solar system and everything else orbits around it. So the idea of the sun being the center of our solar system, that's known as the heliocentric model, okay? But that hasn't always been the case. Many years ago, it was believed that the Earth was the center and that everything else orbited the Earth. This was known as the geocentric model, okay? So geo meaning land at the center. So years and years ago, this model up here is what we believed it to be, okay? The Earth was at the center, everything else, including the moon and the sun, orbited around the Earth. But now with advances in scientific discovery and better telescopes and so on, we now know that the sun is the center of the solar system. Everything else orbits around that, including ourselves. Okay, so us and all the other planets, we orbit around the sun. That's the heliocentric model. The geocentric one was the one with Earth. Now, that can be one example of a question which does appear in the final paper. The question normally comes up with outline one way in which our scientific understanding has evolved or changed over time. This is a perfect example to give for that. You could mention about how in the geocentric model, we used to believe that the Earth was the center of the universe, everything orbited around that. Now we know in the heliocentric model, it's not the case. The sun is the center of the solar system. Everything else revolves around that. Okay, so that is an example you could use for that particular question. The planets then are the next thing we're going to focus in on. This is a very, very common exam question. So for something to be classified as a planet, there was obviously the famous case a couple of years ago where Pluto was declassified as a planet and later classified as a dwarf planet. But for an object to be classified as a planet, 3 criteria need to be satisfied. It must orbit a star, okay? The star we orbit is the Sun. The planet must be large enough to be spherical or roughly spherical in shape. You're never going to have a perfect sphere, but it has to be large enough to be roughly spherical in shape. Okay, and it also has to have cleared its neighbourhood of objects like itself. Okay, so it has to have a clear orbit. So if all three of those criteria are satisfied, it's classified as a planet. Even if it misses out on one of them, it cannot be classified as a planet. So really important that all three are being met before an object is classified as a planet. So in our solar system then, we have 8 planets. We can see them here in the diagram. We have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus and Neptune. Now I mentioned these planets on the last slide, so just to spell them out here, we have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus and Neptune. Now it is important that we do know those, and they are actually listed there in order of closeness or proximity to the Sun. The first one being Mercury, closest to the Sun, and then Neptune being furthest away. So if you want to remember which one is which, or a little device for remembering all of these, if you just remember my very excited mother just served us nachos. Okay, because if you look at the first letter of each one of those, it links up to the first letter of the planet. Okay, so really important that you do know the 8 names of the planets, but do also know the order of them as well, because that can come up as a question, knowing which one is closest to the Sun and which one is furthest away. Now, I mentioned already about the famous example there of Pluto being demoted as a planet. So dwarf planets do not meet the criteria to be planets, okay? So think back to the 3 criteria. They don't meet all 3. For example, Pluto is spherical in shape, so it meets that one. It does orbit a star, so it meets that one, but it has not cleared its neighbourhood of objects like itself. Okay, so it was declassified as a planet a couple of years ago, and it is now referred to as a dwarf planet. So dwarf planets, they don't meet all of the criteria to be classified as planets. Pluto, again, being the famous example of that. Now, this is actually one of my favourite definitions which comes up in science. So we have the idea of a satellite. I'll come back to that in a second, but we will eventually break the satellite down into natural satellites and artificial satellites. So by definition, a satellite is an object which orbits another object which orbits the Sun. Now, how does that make sense? Well, a famous example of a satellite is our moon. Okay, the moon is an object which orbits another object which in turn orbits the Sun. Okay, so that's the definition there for a satellite. An object which orbits another object which orbits the Sun. Okay, moon is an example of a natural satellite. Okay, it's one of the celestial objects that happens to be a satellite because they orbit another object which orbits the Sun. We can have artificial satellites as well. So these are satellites which are intentionally sent into space. Okay, so the moon being an example of a natural satellite, artificial satellites are ones which are intentionally put into space. But they too are technically classified as satellites because they will orbit another object which orbits the Sun. Okay, so that's the satellites. Comets then. A comet is a ball of frozen gases, ice, rock and dust composed of many of these. When they come in close contact with the Sun, the ice and the gases are going to melt given the temperature of the Sun, and it's going to form a tail which gives the comet the distinctive look. Okay, so the tail is always formed behind the comet. So if we have a look at this diagram over here on the right hand side, we can tell that the comet here is moving towards the Sun because there's the brightest point there, and we can actually see that the tail is forming behind it. Okay, the ice and the gases are melting and that's what's forming the tail. Okay, so if that's ever asked, we can say that the comet is moving in this direction here. An asteroid then is a small rocky body which orbits the Sun. Okay, so they're composed entirely of rock, and the majority of them are found in the asteroid belt, and that's located between Mars and Jupiter. So many of these asteroids will be found there, not really doing anything, they're just in orbit, but from time to time they can actually catch on fire. The reason for this is because when they move, a frictional force is applied. Okay, and from time to time, if that frictional force is really great, heat can be produced, and then it can start to burn. Okay, so from time to time that can happen. But just remember, asteroids, they're small rocky bodies composed of rock. Majority of the time they're found in the asteroid belt. Okay, so we're going to have a quick look at a question that's appeared in an exam before based on all of this. It's actually 2 questions here. Answer questions A and B by placing a tick in the correct box. A star and all of the objects that orbit it is called, is it A, a moon, a solar system, or a galaxy? Well, it's not a moon, because a moon is a satellite. That's an object that orbits another object that orbits the sun. A galaxy is a collection of solar systems and lots of stars associated with that. And then the solar system is actually the required one here. That's a star and all of the objects that orbit it. A system of billions of stars is like a moon, a solar system, or a galaxy. This one here we mentioned a couple of minutes ago is the galaxy. Question 2. The images below show 3 celestial objects which are found in our solar system. The objects are not shown on the same scale. So we have a moon, we have a star, and we have a planet. Match the name of each celestial object with the correct description in the table below. So consists of burning gas, that will be the star. Orbits a planet, that's going to be the moon, that's a satellite. And orbits a star, that's the planet. So our planet orbits the star, which is the sun. The moon orbits a planet, which in our case is Earth. Which of the celestial objects above has the largest diameter? This is going to be the star. Okay, it's the biggest one in our solar system. Okay, so that was all the celestial objects. And for the next couple of minutes, we're going to focus in on the Earth, and more specifically, the Earth's tilt and how this is responsible for the seasons which occur on Earth. So the Earth's axis is an imaginary line that links the North Pole up here and the South Pole down here. So there isn't actually a physical line or a physical pole that goes through the whole of the Earth. It's just an imaginary line linking the North Pole and the South Pole. Now this tilt has been calculated to be at an angle of 23.5 degrees. Okay, so if we were to calculate this angle in here, it's 23.5 degrees. When the Earth spins, half of it is going to face the sun at all points and the other half is going to be in darkness. It's not receiving light from the sun. It takes 24 hours to complete a full spin. Okay, so for some of the day, obviously during summer we have longer days because we're tilted more towards the sun, which we'll come to in a couple of minutes. In winter we're tilted more away from the sun, so it's never really going to be a full 12 hours sunlight and daylight. It is going to change because of the tilt, but half of it is going to face the sun, the other half is going to be in darkness. So this is a depiction of the Earth's seasons. So the Earth's orbit, its axial tilt, and the seasons. So right here in the centre, we have our sun, and we can see that in each one of the diagrams, we have the same tilt. Okay, it's roughly 23.5 degrees. So the first one we're going to have a look at over here is the idea of summer in the northern hemisphere, which is where we exist. So in summer in the northern hemisphere, we can see here we're tilted toward the sun. Okay, we're in the northern hemisphere, we're tilted toward the sun. So this is why we have really nice long days, we have nice weather. But in the southern hemisphere, this is when it is winter for them because they're tilted away from the sun. Okay, so they're not receiving as much sunlight, days are shorter, weather isn't as good. Now over here, when we're tilted away from the sun in winter, okay, it's winter in the northern hemisphere, we're not receiving sunlight. Okay, the weather is a little bit poorer, it's a little bit colder, but the southern hemisphere is getting really nice weather. It's summer in the southern hemisphere. So that's why when we're celebrating Christmas over here, if you know anybody that might be in Australia, for example, they might actually celebrate Christmas Day on the beach because the weather is so good down there. Okay, they're in the southern hemisphere, they're tilted toward the sun, we're tilted away from the sun. Okay, and then spring and autumn are kind of in between. So between summer and winter, we're beginning to tilt away. So the days are getting a little bit shorter, the weather is getting a little bit poorer until we get into winter time when we are not receiving sunlight. Opposite happens then in spring, so we're beginning to get to a point where we're tilting toward the sun, so the weather is getting a little bit better. But in all of these cases, we are tilted at 23.5 degrees. Okay, so at summertime, we have longer days, we're tilted toward the sun. Wintertime, we're tilted away from the sun. So that's the seasons. So when we actually mention a season, it's just a division of a year. Okay, so we divide it into 4 seasons. So we have summer, autumn, winter, and spring. Okay, there are 4 3-month divisions of the year. In winter, okay, so say November, December, January time for us, the northern hemisphere is tilted away from the sun. This results in shorter days and colder weather. But in summer, the northern hemisphere is tilted toward the sun. This results in longer days and warmer weather. The southern hemisphere is the direct opposite of that. We've went through this already, we'll just have a quick look at it again. So there's summertime, we're in the northern hemisphere, we're tilted toward the sun, so we're going to get longer days, better weather. The southern hemisphere is not going to receive that. For our winter, the northern hemisphere is tilted away from the sun, so we have shorter days, colder weather. The southern hemisphere is actually going to get the better weather here. And then in spring, that's when we're beginning to tilt toward the sun, so we're starting to get nicer weather. In autumn, we're starting to tilt away from the sun, so that's when the poorer weather will begin to start. Okay, so that's the seasons. It's just a division of the year. We've summer, autumn, winter, and spring, and it's because of our tilt. Are we tilted toward the sun for longer days and better weather, or tilted away from the sun? So we're going to be focusing on the moon now for the next couple of minutes and the phases of the moon. Okay, so why does the moon look different when we look it up to the sky at night? So just before we move on to that, just to come back to the definition, a satellite, it's an example, a moon is an example of a satellite. It's a natural satellite. A satellite is an object which orbits another object which orbits the sun. So the moon is an example in this case because it orbits the Earth orbits the sun. So it comes back to the definition, an object which orbits another object which orbits the sun. Now, the moon orbits the Earth every 27 days, okay? So once every 27 days, it'll be back in the same position it started. But it also rotates once on its own imaginary axis every 27 days as well. So not only do we have our Earth here, we have our moon out here. So once every 27 days, the moon is going to return to the same position. But at the same time, on an imaginary axis, the moon is also spinning, okay? So it rotates once on its axis every 27 days. So that's a really important note to mention there. The moon's orbit and axis rotation are approximately the same length. Okay, and it's because of this, I'll write this down here, okay, so it's because of that we only ever see one side of the moon. It's because the moon orbits the Earth every 27 days, but it's also rotating on its axis every 27 days. So because they're approximately the same, that's why we only ever see one side of the moon. And you might have heard the other side referred to as the dark side of the moon. That's the side of the moon that we don't actually see. Now, important to note here as well, the moon also has no atmosphere and is covered in large craters. This is as a result of large rocks crashing into it, and you can see some of those craters in the diagram over here. Okay, so that's the moon. Now, we've mentioned this already about how we're always seeing the same side or the same face of the moon, but we're not actually seeing it all at the same time. Okay, there's a period of the month where we will see it all. Other than that, we're not going to see it all, and we'll only see little segments of it at a time. So the same side of the moon is always facing us, but it is not always lit by sunlight. So really important to mention here as well that the moon is known as a non-luminous object. And the reason for that is because it does not emit light. So yes, we can see it. It looks bright from time to time, but that's the light of the sun. The moon itself is not actually emitting any light there. So it frequently looks like the moon is changing shape, but this is just the amount of light shining on it changing. So if you can see the full moon, that's because the entire thing is being lit up by the sunlight. In this example over here, it's only the segment over here that the sunlight is falling onto, and that changes from night to night. So these changes with the amount of light that's falling on it is known as the lunar phases. Now, the term waxing, we have two terms that we need to know here. We have waxing and we have waning. So if you were to go out to the sky tonight and look at the moon, then go back tomorrow night, and then go back the next night, and go back the next night again, if it appears that from night to night the moon is getting bigger, or you can see more of the moon, or more of the moon is lit up by the sunlight, that term there is waxing. Okay, it's getting brighter. Okay, waning, on the other hand, is where it appears to get smaller. And just one more thing to note on this as well, it will always start from the right hand side of the moon. So if you couldn't see any of the moon at all, if it was in total darkness, it's from this right hand side that it will start. So at the minute, this moon here is in the waxing phase because every night it's going to get bigger and bigger and bigger until we can eventually see the full moon. Then from the right hand side again, it's actually going to start to get darker. So it will start to get darker and darker and darker until the full thing is in darkness, and then it will start to get brighter again. So just remember that for now. We will come back to it in a couple of minutes. It always starts to either get brighter or darker from the right hand side of the moon. So this is the phases of the moon. We're going to go through each one of them now for the next couple of minutes. So the very first one here, this is our new moon. Okay, so where there's no light falling on the moon, that's number 1. Okay, that's our new moon. Following on from that, we have a couple more terms which we need to know. We have our crescent moon, which you might have heard of before. This is where less than half is lit up. And we also have a gibbous moon. This is where more than half is lit up. Okay, obviously the crescent, you can have a small crescent. This technically here, if I draw an extra line in here, that too will be a crescent moon there as well, because it is slightly less than half. So the crescents can be bigger or smaller depending on how much of it is lit up. So number 1 was the new moon. None of it is lit up. Okay, following on from that, it's always going to come in from the right hand side. So if it's in complete darkness, it's first going to start to light up. So it's going to start to get brighter from the right hand side. So stage 2 is the waxing crescent. Okay, why is it called waxing and why is it called crescent? Well, it's firstly called waxing because it's appearing to get brighter. As it goes from 1 to 2, it's starting to get a little bit brighter, and it's also called a waxing crescent because less than half of it is lit up. If you have exactly half of it lit up, that's known as the first quarter. Follow on from that, it's going to get a little bit brighter again. It's still appearing to get brighter night on night. It's getting brighter as we go from 2 to 3, brighter as we go from 3 to 4. So it's going to be called a waxing moon, but because more than half of it is now lit up, it's a waxing gibbous moon. Okay, so we're combining waxing and waning with gibbous and crescent. Okay, we'll get to the waning one in a minute. Stage 5 then, this is our new moon. This is when we can see the full thing. Okay, I'll come back to that in a second. 6, once it's been fully lit up, it's going to start to appear to get darker. If it's starting to get darker, that's the waning moon. Okay, it's getting darker from the right hand side. It's coming in from the right hand side again. But it's a waning gibbous because still more than half of it is lit up. We will have our last quarter, so that's number 7. And then number 8 is going to be our waning crescent. So it's still getting darker in from the right hand side, but less than half of it is lit up now. So it's a waning crescent. And then eventually all of it will be in darkness. So we will start off with our new moon again. Now, one thing to keep in mind, generally we will have 1 full moon per month. Per calendar month, that is. Okay, so say once in January, once in February, once in March. If we get a second full moon in the same calendar month, that's referred to as a blue moon. It doesn't actually mean that the moon is blue. It's just the term that's used for the second full moon in one calendar month. Doesn't happen all that often, but it is important to know. So the terms you need to know here are waxing and waning, and then gibbous and crescent. Okay, they're really important. So waxing, waning, gibbous and crescent, they're all the phases of the moon. And it can come up as a question as well to be able to name the phase of the moon just by looking at one of these diagrams down here. So the first thing I would look at, is it more than half? Is it less than half? If it's more than half, it's gibbous. If it's less than half, it's crescent. Is it getting brighter from the right hand side or is it getting darker from the right hand side? If it's getting brighter, it's waxing. If it's getting darker, it's waning. Okay, so we talked through this already, but we're just going to put it down into text now. So very first we have our new moon. So this is where none of the moon is receiving light. So we see the side of the moon not receiving light. It looks like it's in darkness here. Okay, that was number 1. Following on from that, we have our waxing crescent. So as the moon moves, a small fraction of it is lit up by light for us to see. So we can only see a small little bit of it. It's a waxing crescent. We then have our first quarter. So this is where it still gets bigger. The crescent waxes, it appears to get bigger, and it looks like half of the circle we can see is lit up. Okay, that's the first quarter. Number 4, this is our waxing gibbous. So it still appears to be getting brighter. More and more light is falling onto it. It's termed gibbous because more than half of it is lit up by light. Number 5 is our full moon, so we see the entirety of the side lit up by the sunlight. Obviously, there's still a full side of the moon that we can't see that's in darkness on the other side, but the side that we can see is fully lit up by light. We then have our waning gibbous, so it appears to be getting darker now, it appears to be getting smaller, but it's still more than half lit up, so it's a waning gibbous. We then have our last quarter, our third quarter. It continues to be in the waning phase, and half the side that we can see is still lit up. The other half has now gone completely dark. We then have our waning crescent, so it still appears to be getting darker, or still appears to be getting smaller. Less than half of it is lit up in this case, so that's why it's referred to as a crescent. And then eventually we will go right back to the start here to our new moon, where it all appears to be in darkness, the side that we're seeing, and the entire process then will start again. Okay, so that generally happens the same amount of time that the moon is going to rotate on its axis, between 27, 29 kind of days. So somewhere around that time frame. It will go through the exact same phases again and again and again. And just remember, if you ever do have 2 of these full moons in one calendar month, the second one is referred to as the blue moon. Okay, so we're now going to combine the sun and the moon and the earth, and we're going to start to have a look at eclipses. So there's 2 types of eclipses. We can have lunar eclipses, or we can have a solar eclipse. Okay, so an eclipse occurs when the light of the sun is blocked by either the moon or blocked by the earth. If we have a solar eclipse, we're going to end up with this over here. So it's where the moon positions itself between the earth and the sun, and it looks like the sun is blocked off. We can only actually see the outside of it. A lunar eclipse, the earth's shadow is essentially falling onto the moon, so it appears more darker than it usually is. So that there would be the lunar eclipse. Now we're going to focus first of all on the solar eclipse. We look at a diagram of how this actually forms, and then we'll move on to the lunar eclipse. So a solar eclipse occurs when the moon positions itself between the earth and the sun. So really roughly here, we have our sun, we have our earth over here, and the moon is going to position itself in here. Okay, so the moon is positioning itself in here, which means that if you were standing on earth, the moon is actually blocking it, and it appears that the full thing is covered. You can actually only see the flames on the outer surface. So that's the solar eclipse. We look at a more detailed diagram in a couple of minutes. The lunar eclipse, on the other hand, then, during the lunar eclipse, this is where the shadow of the earth is going to fall on the surface of the moon. So we have our sun over here, we have our earth over here, and we have our moon over here. So the sunlight that's trying to come from the sun is going to be blocked by the earth, and this is going to cast a shadow then onto the moon, and it's going to appear like this over here. Okay, so that's the lunar eclipse, and again we'll have a look at a proper diagram of this in the next minute or so. Okay, we're going to start off with both of our eclipses here and look at diagrams associated with them. So we'll do the solar one first, and then we'll move to the lunar one. So we have our sun, we have our earth, and in between we have our moon. Okay, so if you were standing here on Earth, what we should see is that the light from the sun is being blocked by the moon. Okay, doesn't matter what direction this sunlight is trying to go, it's going to be blocked. Like so. Okay, so what's going to happen if you were standing here on Earth? It's going to look like the sun is completely blocked off by the moon. You will only be able to see the outside flames. Okay, we're going to form 2 different areas in here. This area in here, which I'm about to do in green, normally I do it in grey, but just to make it stand out, that area there is called the umbra, which I will explain in a second. And this region out here, which I will do in red, that's called the penumbra. So before I get to those, just imagine yourself, you're standing here, you can only see the outside of the sun. This is a solar eclipse because the moon has positioned itself here in the center and is blocking the sun. Now, just to mention those 2 terms, umbra and penumbra, this is going to be the same for both types of eclipses. The umbra is the darkest shadow, and this is the lighter shadow. Okay, so that's just important to know. We would actually have our darker shadow in here. This would be the lighter shadow out here. Okay, that's the solar eclipse. Now for the lunar eclipse, we still have the same objects. So we still have our sun. Our earth is going to be here in the center. And we still have our moon. So it doesn't matter where the sunlight is trying to come from, it's going to be blocked off by the Earth, and shadows will start to form again, which I'll get to now in a second. Okay, so not the most perfect diagram, but you get the idea. That will continue on. They'll eventually meet. So we have our two regions again. We have our umber region and our penumbra region. This is going to be the darkest shadow in here. That's the umber region. This is going to be a lighter region out here. Okay, so that's our umber region. And then that's our penumbra region. So what's happening in this case? Well, the light from the sun is going to be blocked by the Earth, and a shadow is going to be passed onto the surface of the moon. So it's going to appear that the moon is in darkness. We'll still be able to see the outline of it. It's just going to appear slightly darker than it normally would. Okay, there's a shadow after being cast onto the moon. So that's the difference there between the solar eclipse and the lunar eclipse. It is really, really important to know those diagrams. I will show you proper diagrams that I didn't draw on the next slide, but it will be the exact same idea. Really important that you know those. So here it is again. There's the solar eclipse, which is the first one we looked at. The sun and the Earth, the moon is going to position itself in between. And if you were standing here on Earth, the moon is actually going to block the light coming down. So it's going to appear that you can only see the outside of the sun. The rest of the sun is going to appear like it's covered by the moon. For the lunar eclipse up here, the moon is going to position itself behind the Earth. The sunlight that's coming from the sun is going to be blocked by the Earth, and then a shadow is going to be passed down onto the moon. Okay, you'll still be able to see it. It's just going to appear slightly darker. Okay, and the two regions we have our umber region and our penumbra region. The umber region is the darkest portion of the shadow. The penumbra region is the lighter portion of the shadow. Okay, so just to finish up, we're going to look at a couple of exam questions based on the entire content which we looked at today. So the photographs below show the moon as seen from the Earth at certain times during the lunar cycle. The images are not in the correct order. Answer questions A, B, and C by putting a tick in the correct box. So which image, 1, 2, 3, or 4, shows a new moon? So a new moon is where we can't see it. The full moon is where we can see it all. So the one here where we can't see it is image 4. Which image, 1, 2, 3, or 4, shows a moon during a waxing crescent phase? So crescent phase is where less than half of it is lit. So that would pinpoint towards this one here. A waxing phase is where it's getting brighter from the right hand side. It actually meets that criteria there as well. So that's image 1. Approximately how long is the lunar cycle? That's roughly 1 month. Okay, between 27 and 29 days, so roughly 1 month. And explain why the moon is visible from the Earth. So we can say here the moon is non-luminous. It does not emit light. But we can see it because it reflects light from the sun. Okay, so that would have been the answer there for that. So this question here, the diagram below shows the Earth orbiting the sun. Complete the diagram to show the shape, location, and motion of the moon. So the moon is going to be roughly here. And it's also going to rotate or orbit around the Earth. Okay, so that's the moon. At the time of the first landing, the moon was in a waxing crescent phase as seen from the Earth. The images below show different phases of the moon in sequence from left to right. Place a tick in the box beneath with the image which shows the moon in a waxing crescent phase. So actually only one of them is in a crescent phase. This is one of the quarters, this is the gibbous moon, this is the full moon, this is the only one with a crescent. So that's this one here. Shade in the image of the moon on the left to illustrate the next phase of the moon in the sequence above. Now remember, when it starts to get lighter and when it starts to appear to get darker, it comes in from the right hand side. So here it was getting brighter from the right hand side, brighter from the right hand side, even more bright, even more bright. Now it's going to start to get darker, okay? But it's going to be a waning gibbous moon. So only this portion of it here is going to be shaded off because more than half of it is going to be lit up. So on January 2nd, 2019, the Chinese Chang'e 4 lander touched down on the far side of, or dark side of the moon. Explain why this side of the moon is never visible from the Earth. So the moon rotates on its axis at the same rate it orbits the moon, or it orbits the Earth. Okay, so it's much the same rate as when it's rotating on its axis as it is orbiting around the Earth, so that's why we never see the dark side of the moon. You actually needed both of those points there for full marks. You need to mention the axes and you need to mention the orbit around the Earth as well. Draw a label diagram to show the positions of a moon, a star and a planet during a lunar eclipse, so an eclipse of the moon. So this was one we seen earlier on. So there's your sun. We have our Earth. Our moon is going to be over here. Doesn't matter where the sunlight is trying to come from. It's going to be blocked off by the Earth. Okay, we'll have our umbra region in here. We'll have our penumbra region in here. And the shadow of the Earth is going to be cast onto the moon, making it look like it has a shadow and it's going to appear more dark. Okay, so that's the lunar eclipse. And final question for today. The diagram shows the movement of the Earth around the Sun. The letters A, B, C and D represent 4 positions of the Earth as it moves around the Sun. Starting at position A, what will be the position of the Earth when 18 months have passed? So this happens once every 12 months. So this is going to be 3 months, 3 months, 3 months and 3 months. So in 12 months, it's going to be right back to where it started. So in half of 12 months, in half a year, it will be over here at position C. Which letter A, B, C or D represents the position of Earth during summer in the Northern Hemisphere? So in the Northern Hemisphere, we have to be tilted toward the Sun. So that is going to be here. The Northern Hemisphere is tilted toward the Sun here. So that's position A, and we know that because it's tilted toward the Sun. Part C, select your letter A, B, C or D which represents the position of the Earth when day and night last approximately the same length of time. So this is going to either be B or D. And then which one of the following statements explains why seasons occur on Earth? The moon moves around its axis, the tilted Earth moves around the Sun, the tilted Earth moves around its axis, or there are sunspots on the surface of the Sun. So this is the tilted Earth moves around the Sun, okay, which we came across earlier on. So that's a selection of questions which have come up on the phases of the moon, the seasons, the eclipses and the celestial objects. Okay, they're very accessible questions. Lots more questions have come up on these particular topics, so do make sure and go back and have a look at those as well, because they are very similar questions and there is a lot of repetition within them. Now, just before we go, I do want to show you around the ExamRevision website where you can access more content just like the content where we worked through today. Now, when you go to the ExamRevision website, examrevision.ie, and log in, you'll see that we've lots of different junior cycle subjects other than science as well. So we've business, geography, history, home ec, Irish, maths and science. All of them are laid out the exact same way. So we've video tutorials, we've quizzes, we've presentations, an exam builder and a resource pack. Now within the video tutorials, today we were looking at Earth and space, and one of the things we looked at was the seasons, the lunar phases and the eclipses. So you can click into the videos, watch back over all the content again and again at your own pace. You can change the playback speed to make it a little bit faster or a little bit slower, and there is related videos there for you to watch as well. Now, if we go back to the home screen, we can see here, not only do we have the videos, we have quizzes. So there's an MCQ quiz there, 10 questions which you can click through and test your knowledge. We do have a PowerPoint presentation where you can get extra information. We have a resource pack which you can use in class, and we do have our exam builder as well. So again, not only are all the past state exam questions here, all the past mock questions are here as well. So you can have a look through those, pick whichever ones you want to add into your own exam. And when you go back up here to the top, you have the option to download the questions and download the marking schemes so you can test your knowledge as well. So do check out the ExamRevision website. We do also post some updates there about our live revision courses. So these are 4-hour revision courses which happen usually during the midterm breaks, but also at Easter holidays and in May, June in the lead up to the exam as well. So it's an intensive one-day course going through a lot of the material which will appear on the final exam. So keep an eye on our website and social media channels for information about those. Do keep an eye on our social media as well for upcoming updates about our other Saturday sessions. So there is lots of other Saturday sessions other than the junior cycle science ones as well. But thanks a million for joining the science one today, and I hope to see you at another science one very soon.